Hello, I'm John Nightingale, a director at JCT and the Symposium host. Now, the 25th JCT Traffic Signal Symposium was an online event this year, and I'm delighted to bring you a recording of one of the presentations. Now, these recordings would not have been possible without the support of a select group of our event partners. So our thanks go to the Institute of Highway Engineers, ITS UK, keepadistance.co.uk, Siemens Mobility, TWM, and of course, our media partner, Highways News. Please check out their short videos, which will tell you about some of the products and services that they can provide. Now, I hope you enjoy this presentation, and we would love to see you in person for our 25th anniversary event in Nottingham Trent University in September 2021. Hope you enjoy it. Thanks.
Thanks very much, Paul. John as well. I appreciate you inviting me back for another session this year at JCT. Unfortunately, without an audience this year, so I'm missing a little bit of crowd interaction, but yeah, I'm sure we'll make do. I hope you can all see this. I'm Alex Verploegh. I'm the product manager within Dynniq for CITS and inflow, our adaptive control method. And I'm hoping to share a little bit of insight from you on a partnership that's been going on in the Netherlands called Talking Traffic, focusing on creating kind of a standards framework and a best practice approach how to deliver data capabilities and in-vehicle services into the market. So I'll be talking about what the partnership entails and what specific problem it addresses. What is Talking Traffic doing about solving that exact problem? And I'll be sharing some initial results from you from a report that's been published just last month. So first formal evaluation report, very interesting insights so far. Although I say Talking Traffic is kind of work in progress by this partnership, I'm pretty sure, and I'm sure many of you will agree, and this is where I'm kind of missing the crowd interaction, that you all have seen examples like this of talking cars. So I think Talking Traffic already kind of exists, and this is more recent. But ultimately, all joking aside, I think what we're trying to get to is an ecosystem in which vehicles can share data openly and communicate with infrastructure in a way that is well understood across suppliers and local authorities in order to improve benefits for road users. So before we do that, a quick overview of how we at Dynniq serve the market. There's three kind of primary pillars, if you will. There's an infrastructure pillar that we do, traffic control maintenance. We primarily have that in place to improve safety and guarantee safety to road users. We have a smart mobility pillar on top of that, where you'll see UTMC and adaptive control methods sit, which is kind of making better use of infrastructure and control techniques to improve operational efficiency. And then lastly, and this is where I'm more active in, is the cooperative corridors pillar, which focuses on CITS services. So it's more towards active intervention and user behavior type work, such as TMS GLOSA or CITS type services, which are hoping to personalize customers' road user experiences and make better use or maximize the value of data that's available to us. So it's much more about a sustainability aspect and doing more with what we have with data specifically. They build on top of each other, and I'll kind of go into a little bit more detail as to how that works when we get to Talking Traffic. So just to share a little bit of context, the scale-up of connected vehicles, we've all seen and heard it in the news recently. This is what we think will undoubtedly happen. We'll start moving from vehicles sharing their positions to moving to sharing intentions, being fully connected to 5G networks in future, being fully automated, obviously, and being able to share coordination maneuvers ahead of time with traffic management control centers or systems. And I think this plays well into the cards of CITS in terms of what we do in the interim. So with that said, there is no clear-cut approach to enabling these types of services in the vehicle. We have seen examples of this. As I mentioned, we're involved in the York project, where we're working on getting this to the public. And Talking Traffic was looking to address an issue of not having a common standards framework available to them in the Netherlands, and no common way of interpreting or using CITS message standards and bringing those services into the car in place across the industry. So what the questions they were asking themselves was what infrastructure would need to be in place in order to make use of that data and unlock it in the first place? How would such a framework and what standards would be needed to enable data to become free-flowing and accessible to road users via third parties? How would local authorities benefit from this? And obviously the private industry as well. And how would the road user benefit from, let's say, more effective targeting of this information, or more personalized information than before? So to sketch this a bit, we see from the Dynniq cooperative and autonomous driving roadmap to 2030 that in the position we're at now, there's a large tendency to focus on roads, and that will move towards connectivity as more connected vehicles appear on the roads today. And I'm just highlighting kind of a couple of trends that the report highlights in saying we need to be very careful in what we say here, but take note of things like human interaction research, digitization of assets, and cooperative data sharing to be able to effectively plan and provide investments to this end. So what does talking traffic actually do in that regard? How is it making use of these trends, and how is it playing into the fact that connected vehicles are becoming more common? I think the collaboration between the Dutch Ministry of Infrastructure and Water Management, 60 regional and local authorities, including 20 private industry companies, demonstrate that this is a very national and very broad approach to fixing that problem. The focus was very much on, like I said, retrieving and unlocking traffic management data in order to get more value from it, both for authorities and for road users. It lays the connection, it lays the foundation for this connected and autonomous driving by presenting this framework and best practice way of using existing messaging standards to make use of it better, to improve sustainability, efficiency, road safety, and ultimately help reduce public expenditure associated with purchasing or tendering for such technology. There's a website below if you feel interested and want to read more about this. So fundamentally, what does it do? How is this broken down? It focuses on 3 primary clusters. The first cluster is focusing on making data available from infrastructure, so unlocking existing assets and data that it collects. The second cluster then makes that centrally available via cloud platform services. I'll go into a little bit more detail about that later. And third, but definitely not least, it is making use of that data and repackaging it into, let's say, more tailored or personalized information services to road users. So fundamentally, that's the setup of the program. And what does this mean? It means there are a number of use cases that you can think of, roughly speaking, that come into play when making your road user services available. They've been categorized into 6 rough groups. I'm not going to go through all 39 use cases, but you'll get a feel for the types of services that have been thought of. Things like in-vehicle signage and speed advice, priority of traffic signals, presenting generally in-car information such as replicating signage, but then based on a vehicle's position, optimizing traffic flow through what we call ITS applications, or as you might know, it's ScootMova or Inflow, and in-car parking information, for example. This is a very simplified overview, but a very comprehensive one of who's involved, what the ties are between the industry sectors in the Talking Traffic Partnership Program, and how they work together and collaborate on creating the standards to enable these types of services to become kind of real and deployed. So on the left, you'll see my cursor. The first cluster is, like I said, talking about creating, let's say, intelligent traffic lights and being able to exchange data between traffic control centers or traffic light control mechanisms, pushing that into cluster 2, cloud data platforms, which are the main partners mentioned there, but they can also be enriched with additional external data feeds. Think of UTMC, common database type systems, or something like Elgin, which could enrich the data that's accessible on top of traffic light controller data. OEMs and tier 1s and emergency services or logistics and public transport can contribute there as well, or make use of the data. And then following from that, we have a central repository of this data and associated standards with getting to it. And now third parties can start packaging that information into services such as Flitsmeister, which is an app that shows speed advisory messages or in-vehicle signage on top of, let's say, mobile traffic cameras, which is very popular in the Netherlands. And this focuses on not just road users as in vehicles, but also cyclists. There's actually an extension for talking traffic being discussed right now that focuses more on talking bikes for bicycles and talking logistics for the logistics sector. So I think the framework in itself has proven to be successful in that regard, but more on that at the end. So what have we at Dynniq done with this? We obviously have a very similar approach to these three clusters. So we've adopted our kind of simplified ecosystem in the same way. We have signals and controllers. We have a central service cloud, which we call FlowSense, which makes data available to third parties or via our own app. We collect that from traffic light controllers. And we have a talking traffic standard that we now use following the talking traffic partnership, which unlocks the data. And that's being used in York right now. And then we make that data available to apps. This is the Dynniq app example on the right there. And we can communicate with apps via either 4G or ITSG5 or in hybrid, depending on what you want. Or we can integrate our app into a third-party supplier if you wish to integrate it into an existing device in the truck or car, for example. And they use ETSI standards, so CITS message standards. So those interfaces I mentioned, what are they exactly? The two primary ones that are very relevant here, like I mentioned before, are the TOCFI, spelled out there. And its main function is to basically, from an operational standpoint, allow traffic controllers to exchange information with CITS applications or ITS applications like ScootMova or Inflow. And then that information via the RIS-FI gets translated into a format that can be consumed by a cloud platform, simply put. So we think about CITS messages and geomatching, which is something I'll touch on in just a second. So geomatching, as I mentioned, is essentially the digitization of roads or signage or assets. And fundamentally, it's broken down very simply by visualizing it as a number of layers on top of each other that contain ranging from static to highly dynamic types of information. They can be layered on top of each other using a local dynamic map. And simply put, when a vehicle approaches an intersection, it'll generate, using its GPS position and an awareness message, a CAM message, which transmits its location every second or quicker than that. It'll transmit its location, and the function of the RIS having an LDM component built in is to map that vehicle onto a junction topology file, which we create and maintain in order to target services for that specific vehicle. So it's very position-based and very personalized. This is something that we use internally. We translate AutoCAD files into a digital variant in order to do that digitization that I just mentioned. And this is the end result. So once we have a full chain running, and this is something we're deploying in York, the Dynniq app, it'll look very similar to what you see here, and it's been showed before, like Paul said, in early stages back in, I think 2016 or even 15 in Glasgow. We show in-vehicle speed advisory messages, time to green, and remaining red time, which primarily focuses on reducing fuel consumption by avoiding or reducing the amount of stops by having people adjust their speed based on the advice that's given via the app. And ultimately, this helps improve emissions, reduces road wear and tear, i.e. maintenance, and helps with fuel consumption. So that's a big advantage that's being evaluated and has been shown to work on various occasions. So some of the examples that are exactly shown by Talking Traffic, you can see here. This is one of the apps that uses a navigation app and overlays the information on top of it. So it's integrated. And this is an example of what it could look like in a truck. It can also be embedded in a telematics device if that's deemed more appropriate. But the main aim is to get the road users to start using this in order to influence behavior. So the evaluation report is out. Some of the first use cases that have been reviewed right now are use case 1. So we're actually seeing, based on 2 corridor projects in Talking Traffic, and in improved road user kind of behavior adaptation to following maximum speed where they're exceeding it, or sticking to the maximum speed better when given a specific speed advice compared to the control group situation, which is very useful and improves safety overall. Use case 2 is we see an observed reduction in speed when given a speed advisory message or warning for hazardous events ahead. So think of a roadblock or roadworks, or even a vehicle collision that's being transmitted. We see, similar to what other reports have been saying, also a 7 to 10% reduction in journey time for logistics vehicles using conditional priority. I think that's a useful use case for corridors that see large amounts of emissions or reaching emission ceilings or even exceeding them. And this needs to be evaluated further, but based on the formal report from Talking Traffic, that's being observed as well. And I think the last use case is an interesting one. There's a cautiously positive effect that's been observed in optimized signal control. So that's proving that the journey time is actually going to be increased depending on the local scenario and chosen policy that's being opted for in terms of compared to baseline. So we're actually using connected vehicle or floating vehicle data on top of detection data or radar or thermicam detection to help the traffic model or the algorithm improve its signal timings or adjust its signal timings in response to baseline, which is just using loops or cameras. So as a result, the partnership is now coming to an end at the end of this year. What are we seeing? I think the results speak for themselves. Using the IVRI viewer website, which is publicly available, have a look if you want on top, you can see which ITLC, so intelligent, and what I mean by that is controllers that conform to the Talking Traffic model, so which they support the standards, and they are CITS compatible to a certain extent. You can see which local authorities are now putting in orders or have already deployed such ITLCs, who the suppliers are, which ITS application or mode of control they operate on, and whether they support CITS use cases. Currently, we see 1,114 ITLCs on order or installed as of the 21st of this month. And half of them actually support conditional priority and vehicle information. It doesn't mean that they use it currently or get service paid for them, but they are compatible with them. And so why did it work? Why has it been so effective? Obviously, as I've said, it's been a nationwide adoption. The government has led and subfunded this. And it followed a rigorous period of testing, collaboration, talking about which standards are most appropriate to be adopted by the traffic industry sector, with people from the traffic industry sector, technical experts talking about, ITLCs, what data and how the data from traffic controllers needs to be made available, and in what format that would need to be. And they also chipped in themselves because buying into the partnership meant, longevity of the market and a competitive position. And we've actually been feeding that information from the Netherlands into the C-Roads platform, which looks to create a very similar framework standard in the EU to be adopted all across the EU for countries who participate. So I think that's a really good result. And we've been feeding, particularly on GLOSA and conditional priority, information in from the Talking Traffic report, which is great. And as a result, we're also seeing large-scale adoption. So the evaluation report now is step one. But I think on top of this, we're seeing that the upgrade and future-proofing of said infrastructure is proven to be beneficial, and there is confidence from the market, public authorities speaking here, in that this infrastructure that they buy and the services that they could buy in future are actually going to be future-proofed and are based on what they believe to be the best standard at the time. So with that said, and keeping a close eye on time, I will leave it there. Any questions, please feel free to get in touch with me or take them offline.